Suppose we have the vectors A and B here as shown, and we are given the components of A and B as 4, 3, and 8, negative 6 respectively. How do we find the angle theta between the two vectors A and B? Well, first, because we are given the components of the vectors, we have the information needed to get their magnitudes, meaning to say that we have the information to get this length. We also have the information to get this length. And also, because this side is just negative A plus B, that vector, this vector is negative A plus B. Given the components, we are then able to find the components of negative A plus B. And once we have the components of A plus B, negative A plus B, we will then also be able to get the length of that side, which now is forming the third side of the triangle. So if we have all the sides of the triangle and we look for the value, we look for the size of this angle, and we could just use the cosine rule. Well, it turns out that the cosine rule combined with some vector operations that we learned before will give us quite a handy formula that will make the whole process a little bit shorter. So the formula goes like this. If this is vector, let's say vector V, this is vector W, and we want to find the angle between V and W, then also if we are given the components of each of the vectors, so let's say that the components of V are V sub 1 and V sub 2, and the components of W are W1, W sub 1, W sub 2. Then cosine theta, the cosine of the angle theta there would just be equal to the dot product of V and W divided by the magnitude of V times the magnitude of W. And we need to specify here that the angle we are looking for is this angle here and not this reflex angle over here. So we're gonna add a little bit here and say where theta is from 0 to 180 degrees. So let's go back to our problem a while ago where A is 4, 3 and B is 8, negative 6. It was this and this, and we want to find theta. So according to the formula, cosine theta should be equal to the dot product of A and B, so 4 times 8 plus 3 times negative 6 divided by the magnitude of A would be the square root of 4 squared plus 3 squared times the magnitude of B is 8 squared plus negative 6 squared. All right, let's simplify. That would be 32 minus 18. So the numerator there is 14. We have at the denominator 4 squared, so that's 16 plus 9, 25 square root is 5. This is 64 plus 36, square 100, so square root is 10. So that's going to be our cosine theta. Cosine theta. cosine theta is equal to 14 over 50. So to solve for theta, we're going to need to get the cosine inverse, or the arc cosine of 14 over 50. Now I want my answer to be in degrees. I'm going to use, we're going to need our calculator here. If you want our answer to be in degrees, okay, so the arc cosine of 14 over 50, that would be 73.7 degrees. Let's go back to this formula and look at perpendicular and use it to look at perpendicular and parallel vectors a little bit more. But first, let's write this as, if we cross multiply, we can write this equation as V, or V dot W is equal to V magnitude W cosine theta. Now, what happens to this equation when, say, V and W are perpendicular? So when V and W are perpendicular, it means that theta, the angle between them, if theta is the angle between them, then theta is 90 degrees. So this formula becomes V dot W is equal to, now cosine 90 degrees is 0. So that means that V, if we simplify it, it means that V dot W is equal to 0. So this is a handy thing to remember for perpendicular vectors, that when vectors are perpendicular, then the dot product of the vectors is equal to 0. As for parallel vectors, let's say that V is parallel to W. So two things: either if the vectors are parallel, either the angle between them is 0 or the angle between them is 180 degrees. Now, the formula then now becomes V dot W is equal to magnitude of V times magnitude of W. Now cosine 0 is 1. And so it means V dot W is just equal to the magnitude of V times the magnitude of W. And if theta is 180, the equation becomes V dot W is equal to V magnitude W magnitude times the cosine of 180 degrees is -1. The equation becomes V dot W is equal to negative V. Now actually, we could combine these two equations. The result of these two equations we could just write. One is positive and negative, then we could write these two as just plus minus, this is V dot W is equal to plus minus magnitude of V, magnitude of W. And if you think back to your properties of modulus or absolute value, this expression could actually be written as the modulus or magnitude of V, the dot product, is equal to magnitude of V times the magnitude of W. So this is another handy thing to remember, that when v and w, two vectors, are parallel, then this is what happens. Now let's take an example, quick one. Find t such that a has components -1, 5, and b has components 2, t, and they are perpendicular. So we start with the fact that we have established earlier that when two vectors are perpendicular, then their dot product is equal to 0. The dot product here will be -1 times 2 plus 5 times t is equal to 0. So that's just 5t is equal to 2, t is equal to 2/5.